In this video, we're going to take a look at verifying trigonometric identities. This is the first video, 5.1.1 for section 5.1 in your pre-calculus textbook. So our goal here is to practice verifying trigonometric identities and use identities we already know to do that. So you've already seen some of the fundamental identities that you've used and that we've already discussed. Let's take a look at those in helping us verify this first trigonometric identity. So we have this set of identities that we already know. They include the reciprocal identities, Pythagorean, tangent and cotangent, and even odd. We're going to use these set of identities that you see here in order to help us with the other identities that we're going to work with. So we're going to take this identity. Sorry about that. Let's see here. What's going on? We're going to take this identity that you see here, and we're going to show that the left side is equal to the right side. So we're going to start with, always pick one side. You never want to work with this like it is an equation, because then you are assuming that the two sides are equal. We don't want to assume, we're actually trying to prove. Now, one of the number one strategies I have for you is to change most things to cosine and sine. We're faster with cosine and sine. We're better prepared to deal with them. We also know more about them. For instance, I see that cotangent is related to cosine and sine. I also know that secant is related to cosine. So I'm going to use these two trig identities to help me manipulate the left side of the expression of the equation. So I'm going to take secant of x and change it to 1 over cosine of x. And I'm going to take cotangent of x and change it to cosine of x over sine of x. I'm simply replacing with equivalent values. Now I see some simplifying that I can do. I can simplify by canceling a cosine of x from top and bottom. I now have the expression 1 over sine of x. So this first one we found by using the reciprocal and the cotangent identities. This one we're going to convert. Remember, our end goal was to say that this whole value is equal to cosecant of x. Well, we know that that's equal to cosecant of x by the reciprocal identity again. So that's once we are done. We have gone from point A to point B and successfully shown that those two values are equal. And so we have proved this identity, verified this identity. So it's as simple as that. We're replacing things with equivalent values. Let's try a couple more examples. Hopefully you're writing these down as we go. So our next example that we're going to look at here is we're going to verify this identity. Sine of x tangent of x plus cosine of x is equal to secant of x. So another strategy is sometimes to work with, instead of starting with the left side, to start with the right side. But notice how simple the right side is. A good strategy is not just to pick the left or the right, it's to pick the more complicated side and start with, like we said, changing things to sine and cosine. So we're going to start with the left side once again and convert it to the right side. So our goal is to go from point A to point B by using equivalent statements. So we're going to take sine of x, tangent of x, plus cosine of x, and convert it to secant of x. So let's start with getting rid of tangent of x. Let's take and make it all sines and cosines. So we're going to use this tangent identity again, and we're going to change tangent of x to sine of x over cosine of x. And leave everything else the same. Now I'm seeing that I have some fractions to work with. So we've talked about two strategies, starting with the more complicated side and changing things to sines and cosines. Another strategy is when we have fractions and denominators like we have here, is to start with converting that to one big fraction. I see my end goal is to create secant of x. If I want to do that, I need to change everything to one fraction in order to see that result. So I'm going to start with, let's simplify this fraction. So we know this is sine squared of x over cosine of x plus cosine of x. I'm going to convert cosine of x to a fraction with the same denominator by timesing it on top and bottom by cosine of x. My common denominator is cosine of x, and then I'll be able to add these two fractions. So we're getting one single term then. So let's see, this will just copy down. Nothing's changing on the left. But on the right, I'm going to have cosine squared of x over cosine of x. Okay, so we have a common denominator. Now we can convert this to one simple fraction. And we have the simple fraction of sine squared of x plus cosine squared of x all over cosine of x. Now it's really important to know your fundamental identities because you should notice something about the top identity. The top should look familiar to one of your identities, and of course it's familiar with the Pythagorean identity. So we're going to use the Pythagorean identity to convert that to 1 over cosine of x. Remember our end goal? Our end goal was to convert everything to secant of x while using one last identity. In this case, that 1 over cosine equals secant of x. We can convert this to secant of x. So we made it from point A to point B successfully, and we have verified the second identity. At this time, I'd like you to try checkpoint exercise number 1, 2, and 3 that you will see here. I want you to remember these helpful guidelines in solving trigonometric identities, but try to convert everything to sine and cosine, use common fractions, common denominators, and start with the more complicated side. Bring in your questions into class later and we will answer them there.